Okay, so we're going to start here on linear equations and graphings and writing the equations of lines. Now there's three forms or three ways an equation might look, and the first of these we're going to talk about is the slope-intercept form. Okay, so the slope-intercept form is probably the one that you're most familiar with already, and that's the equation that looks like y equals mx plus b, where m is the slope of the line and b is where we find the y-intercept. Now the y-intercept is the point 0, comma, whatever that number is. The y-intercept isn't b, it's 0b. Okay, and that, no, that's a game of semantics, but I'm kind of picky about that because it's a point on a graph, and a point always has an x and a y coordinate. Okay, so starting off with kind of just recognizing what these numbers are and stuff. If I want to find the slope, and we typically use m for the slope, okay, that is the coefficient for x. So in this case, the slope is 3/7. Now the y-intercept is the point 0, and then this is a -4. So it's the point 0, -4. Don't tell me the intercept is -4, because that's not a point on a graph. Okay, the y-intercept is the ordered pair 0, -4. Now the importance of the y-intercept form is it's actually super easy to graph when they're in this form. Okay. 1, 2, 3, 4. Okay, so I'm going to, because I sketched this out kind of slow, I'm going to count by 2s, okay, on both my axes here. Okay. Now, I start off, and I know one of the points is 0, -4, and that would be right here. Okay, and then my slope tells me I'm going to go up 3 and to the right 7. Okay. And if I go up 3, okay, that's here. And then to the right 7, 2, 4, 6, 7. That'll put it somewhere right around in here, and that gives me, 2 points. I can put a straight line between them and I have the graph. So it does make it super easy to graph these equations. Okay. So now, what if we need to write the equation of the line? Okay, now, the only time I actually use slope-intercept form is when I'm given slope-intercept form when two things happen. You're given the slope is part of the problem, and 2, you're given the intercept. Okay, now, I use any other situation, I use a different way to do it that I think is, to me, a little bit easier. Okay, but it's just a matter of kind of almost a fill in the blank. Here it tells us the slope is -4, so I know that goes in front of the x. That's the coefficient. And it tells me the y-intercept is -2, is 2. Okay, that point 0, 2, so that's going to be a plus 2. So there's my equation of the line. Okay. So if you're given those two pieces of information, it's really super simple, okay, and you don't need to really do any work because it really is kind of a fill-in-the-blank situation. The slope is the coefficient for x. The y-coordinate for that intercept, for that y-intercept, is that number that's at the end. Okay. Now, write the equation line passing through these 2 points. So it doesn't explicitly tell us, but this is the y-intercept. The y-intercept is always when x equals 0. Okay? Now, when we talk about an intercept for a graph, if I look at whatever, the y-intercept is where does it cross the y-axis. Okay? So, this graph might look something like this. I know I'm not drawing things, but anywhere that something crosses the y-axis, that's the point 0 something, because we don't go left or right. We just go up or we go down to get there. So anytime that I see a 0 for the x-coordinate, that's the y-intercept, period. Okay? So I do have the y-intercept, but I don't have the slope yet. So I need to find the slope. And any time that you see this phrase, write an equation, your first thing is to find slope. Now, if it's given to you, great. If not, then we have to use that little slope formula. Okay? And I'm going to, like I did before, I'm going to label some points here. I'm going to call this x1, y1, and this one's the x2 and the y2. So y2 minus y1 over x2 minus x1. So that's going to be 4 over negative 2, which is going to be negative 2. Okay? And I don't need that. Okay. So now I have the slope. Okay. 2. Okay. If you have the y-intercept, just write the equation in slope-intercept form. So this is going to be y equals negative 2 times x plus 1. So when you write an equation, when you see that phrase of a line in particular, sorry, I should have highlighted. So write the equation of a line, the first thing is always to find the slope. Okay? And then if you have the y-intercept, just use that slope-intercept form. Okay? That's the easiest thing to do. Okay. Now I'm going to go through one example of the way you were probably taught how to do this, but I don't feel it's the best way. Okay? But again, I see this phrase, write the equation of a line. So my first thought is find slope. Okay? So again, I'm going to call this one x1, y1, and this point is x2, y2. So my slope, negative 5 minus 1 over 6 minus a negative 3. So that's negative 6 in the top. The bottom is going to be 9, so that's negative 2/3. Okay, so what that tells me so far is that y equals negative 2/3 times x plus something. And now I need to figure out what this value for b is. To do that, you could use either one of the other points that you had, okay, and substitute in for the x and the y. So I could put 1 in for the y, negative 2/3 times negative 3 plus b, and then I could solve that for b. That's 1 equals 2 plus b. All right, because two negatives give me a positive. Those 3's cancel out. And then we're going to subtract 2 from both sides, and we find that b equals a negative 1. So then my equation is y equals negative 2/3 x minus 1. Okay? And it's not hard, and I don't dislike this way of doing it. Okay, but I see people making substitutions into the wrong places all the time, or they go back in and they try to put something like, that, saying that that's the equation line because they're substituting in for x's and y's, and then they're substituting in for b's. And I think personally there's too much substituting of things and it gets confusing. Okay? So I only show this way of doing it, honestly, because you'll probably see it in the book. You've probably been taught that way to do it. But unless I am given the y-intercept, this is not my preferred way of doing it. Okay, I'll show you that in the next section. Now, sometimes we have these word problems because we love word problems, right? So a school purchased a batch of t-shirts from a company. The company charged $3 per shirt. Now, anytime you see a phrasing like that where there's a fixed amount per something, like in this case, $3 per shirt. Okay. This means it's a linear equation. Okay. And that fixed amount per something, okay, that's the slope. Okay. So when I see that phrase, $3 per shirt, I know I have a linear equation and I know my slope is 3. Period. Okay? I don't care what else is in that problem. When I say, now, it doesn't always have to be worded. It might say, for every t-shirt, you pay $3. Okay? There's something going on for each of something, or like your hourly wage. For every hour you work, you earn $10, or you earn $10 per hour. Right? So the phrasing might be a little bit different, but the meaning's the same. Right? So when I see that, I already know linear equation. Okay? So it could be written in this slope-intercept form. Okay? And then I'm just thinking about kind of what y-intercepts are and stuff. Now, for the rest of the question, and then they gave the school a $60 rebate. Okay? If the school had an expense of $960 from the purchase, how many t-shirts? So that's what I need to answer, is how many t-shirts? Okay? Now, there are several different ways you could do this, but honestly, the easiest is to write an equation and then just solve that, because I already know. Now, they got $60 off, so whatever they paid for those shirts, we get to subtract $60. So look, I have a linear equation. Okay. Now, I know the y in this equation is the total cost, and the x is the number of shirts. Okay. And it asked how many shirts, so I don't know what x is, but I do know that that cost was $960. So 960 equals that. Okay. We're going to add 60 to both sides. Okay. So if I add 60, that's 1,020. And then I'm going to divide that by 3. Okay. And let's see, I do not have a calculator, so let's just do this. That's 340. Right, bring down the 0. That's a 2. Right, and it's going to go in 4 times. Yeah. Okay. So 340. So they bought 340 shirts. Okay. All right, so there we go. Okay, so most of the time with these word problems, and I know people don't like word problems a lot, but I look for particular words and phrases that tell me what I'm doing outside of, I don't care that it's t-shirts in schools or whatever, right? What I see is that $3 per shirt, and that information right there, that piece of information tells me a lot about this problem. Okay, that I have a linear equation and what the slope is. Okay, so that gives me a leg up. And then a $60 rebate, and the reason I know to subtract 60 is, well, that's $60 off. And if you take something off the price, you're subtracting the $60. Okay, so that's why I know it's the minus 60 there, because I'm getting a $60 rebate. Okay, then the rest of it is, what do my variables stand for, and what do they give me, and what am I looking for? Okay, the X was the number of shirts, what it was equal to was the cost, and then it gives me a cost and asks about how many shirts. So I know I'm putting another number in for the Y, and trying to find out what the x is. Alright, so I hope this helps a bit, and if you need some more examples and stuff, please let me know.